Hello students, how are you today?
Fine, thank you.
Good. Welcome to mathematics class, grade 8. And today we have students of North Georgian Secondary School. Are you enjoying the mathematics class so far?
Yes, sir.
And are you looking forward to today's class?
Yes, sir.
And the topic is right there in your face, right? Can someone say what is the topic for today?
Venn diagrams.
Yes, what do you think we'll be doing about Venn diagrams today? Do you think we'll be drawing Venn diagrams? Do you think we'll be interpreting Venn diagrams? What do you think? No, actually, what we'll be doing today is focusing on interpreting information on Venn diagrams. Alright? Of course, it will involve us drawing the Venn diagrams too. And do we know to draw Venn diagrams?
Yes, sir.
Let me see those who know to draw Venn diagrams. Raise your hand, let me see. Those who know to draw Venn diagrams. Excellent. Good. So, what we will start off with is a question. So, I will give you a question and then you will answer it. Because I guess you know something about Venn diagrams, don't you?
Yes, sir.
Somebody who do not know anything about Venn diagram? Because if you don't know anything about Venn diagram, what the day for means today, you will learn a whole lot about Venn diagrams. So let us take an example. But before we even draw, before I continue drawing though, can somebody say what is a Venn diagram? Yes, Danica.
A Venn diagram is a pictorial representation of sets.
Wow. Go that again, please.
A Venn diagram is a pictorial representation of sets.
A Venn diagram, Danica is saying a Venn diagram is a pictorial representation of sets. Excellent. Thank you very much, Danica. So we're going to draw a picture here, which we will use to represent sets. Alright? Because we know what are some other ways we can represent sets? The familiar way that we can use to represent sets is, for example, we say A is equal to, and what do we use? Curly brackets. Yes, we say curly bracket 1, 2. These are the elements in the set A. So this is one way in which we can represent the set. But now we're going to represent the set using a diagram. Usually, this Venn diagram is drawn in the shape form of a rectangle. Alright? But I know sometimes some of you take 5 minutes to draw a Venn diagram. But that is not important in this rectangle. Just take your ruler, your free hand, like what I just did, and you draw the Venn diagram. Alright? And you draw the Venn diagram. Now let's consider a Venn diagram here. What does this rectangle represent? Which one of the sets? The subsets or the universal set?
Universal set.
Are you sure?
Yes.
And what is the symbol we use for the universal set?
Capital U.
Capital U. So let us consider this Venn diagram representing a universal set, and we have two intersecting subsets. Remember when we draw a Venn diagram, if you only join the loops if they are elements intersecting. And somebody tell us what we mean by intersecting?
So elements that are common in both sets.
Elements that are common in both sets. Good, correct. So if we have set A and set B, and we have 4 elements here, 5 elements there, 8 elements there, then when we talk about intersection, we will be talking about those elements that are in set A as well as in set B. So observe this diagram here, because I have a few questions to ask you. And I hope that you will be able to answer those questions as fast as is possible. Now let us say that A, now we're going to school. If A represents the number of students who like agriculture, the number of students who study agriculture, and B represents the number of students who study business. So we're dealing with students who study agriculture, those who like agriculture, and those who like business. So here are the questions. First question. What is the number of students who like agriculture?
4.
The number of students who like or who study agriculture is?
4.
Are you sure?
9, sir. sir.
So why am I getting two different answers? Some saying 4, some saying 9. Let me see those who say 4. And now, no, so nobody said 4 just now. Those who say 9, raise your hand, let me see. Why you get 9? How you get 9 for those who study agriculture? Yes, in the agriculture loop, we have 4 persons here together with 5 there. So the number of students who study agriculture, and we have a fancy way of writing all of that which I just said. Number of students who study agriculture or who like agriculture or who are in the agriculture set, we write it as N, open bracket, A. And this alone says everything. It says the number of elements in the set A. But because we know the set A refers to the set of students who study agriculture, well then we would read it as the number of students who study agriculture is equal to, what did you say?
9.
9. And we see that from the diagram there. What about this? Somebody please read this for me. What does this say?
Number of students
Who like business?
I'm hearing the number of elements in set B, but do we know what is set B?
Yes, sir.
What B denotes?
Business.
Business. So please read this again for me. Who's going to read it? Let me see a hand. Yes, go ahead.
Number of students who study business.
Thank you very much. Number of students who study business. Good. How many students study business class?
13.
How did you get 13? Yes, we consider the entire loop for B, and we see we have 5 and 8, which give us 13. Simple stuff, isn't it?
Yes, sir.
Good. Number of students who study agriculture only.
4.
This is equal to 4. What about this?
8.
8. What is that saying?
Number of students who study business only.
Good. What about the number of students who study agriculture and business?
5.
Those who study both agriculture and business.
5.
Are you sure?
Yes, sir.
Okay. We observe, is 5 in the A loop?
Yes,
And is
sir.
it in the B loop?
Yes, sir.
Good. So it therefore means 5 is the intersection of the two of them. So then we can, and there's a special way that we could write how it is in the two of them using the sign for intersection. And are we familiar with the sign for intersection? Number of students in A intersection B is equal to?
5.
Correct. What about this? Tell me this now. What is this equal to?
Number of students in
Okay, it is read the number of students in A union B. But since we know what A and B means, students who study agriculture and who do business, well then we can say it is the number of students who study agriculture or business. We're looking for all of them who study agriculture or business. Alright? They don't have to study both, but it's as if you have two groups. You have the class, the agriculture class, the business class, and you're going to take them now and put all of them in one room. Good? So, how much students in total we have now? 17. How many? Alright, let me see if I can trick somebody. How many students study agriculture?
9.
How many study business?
13.
So if you put all who study agriculture and all who study business in one class, how much will you get?
23.
But you told me the answer is 17, so what happened there? Can somebody say why it dropped from 23 to 17?
Because he did not count in 22.
Because we did not count in the...
Numbers of all.
Alright, let us examine this carefully. Number in A was 4 plus 5. The number in B, 8 plus the same 5. But should we repeat elements?
No, sir.
No, sir.
No. So because we repeated the elements, that's why we ended up at 23. But actually, if we want the union, it will be 8 plus 5, which is 13, and 4 will give us
17.
17. Is that clear?
Yes, sir.
What about this? If I have this question now, last question of this example, what will this be equal to quickly?
20.
Number of students in the universal set.
22.
23.
17.
17.
Some saying 23, some saying 17, some even saying 22. All right, let us see. We have 4 and 5, 9 and 8, 17. Do we have anyone out here? So then we only have 17 students in total. Okay? So this is equal to the number 17. So we have 17 students who we are considering. The students who study agriculture and the students who study business. Did you enjoy that example?
Yes, sir.
Well, then let us consider another example. Observe this new diagram on the board here. Another universal set with two subsets. Slightly different to, the subsets are slightly different to what we did in the previous example. And we have some questions. Here you are required to list, not just to say the number, but to list the elements. List the elements. If we're to list the elements of the set M, what do we say? M is equal to?
The set of
3, 6, 9.
M is equal to the set of 3, 6, 9. What about the set N? What will it be?
2, 4, 8.
Any question? Simple, these two simple to start with. Alright, if we're going to list this set here. What is this? What will this be equal to?
3, 6, 9.
2, 3, 4, 6, 8, 9.
Alright, observe what happened there. Some person started off by saying 3, 6, 9, 2, 4, 8. But then afterwards, some persons corrected and say no, it is 2, 3, 4, 6, 8, 9. So even though we're going to list the union of the sets, we do not just take the one and put it in and then take the second one and add it in. We still try to maintain the order. If it is numbers, we try to list them in order of their value. So we list this set as 2, 3, 4, 6, 8, 9. So the union of the two sets. Are you ready for the next question?
Yes,
Yes,
sir.
sir.
What are the elements we should list there?
Empty set.
Empty set.
Why empty set?
Because there's no intersection.
There's the diagram is showing that there is no intersection. And how the diagram shows that there is no intersection? What about the diagram?
they're not joined.
Yes, the loops are there. No elements in common, so that's why the loops are not joined together. Alright, so once you're looking at a Venn diagram, the loops are not joined together, it means there's no elements in the intersection. Alright, the intersection is the empty set. So we show that this set here is empty. There's nothing inside of that set. Is that clear?
Yes, sir.
Good, we can list that. Take this other one. Oh, and I know somebody don't know what this symbol means. M with this little dash there. Is it to the M with this little dash is? Complement. Now we say the word complement, but then there might be somebody who do not even know what we mean by complement now. So somebody has to say what we mean by complement. Now everybody's silent. What we mean by complement? We know that it means complement. Complement refers to those elements which are outside of the given set. The elements which do not belong to the given set. So for example, if we have a set of males, well then a female has no right being in that set if we say this is a set of males. Alright? So if I'm going to come to this class here and I take out the set of, and I have these 4 males aside, can we say that Varsha is an element of that set? No, because Varsha is a female. Good. So now that we know what we mean by complement of the set, what are the elements in M complement?
3, 6,
5.
Someone is saying 3, 6, and then they stop.
There 5.
Someone is saying 5. Wow. 5, 3, 6, 5. I have some questions to ask afterwards. Yes, who else? 2, 4, 8. All right. First question though. Imagine we have this class here, and I'm going to say, look, take out the set of 4 boys. 4 boys, please stand. The 4 boys, please stand. Now this is a set of 4 boys. All right? Can I go on to say that Shivani is an element of the set?
No, sir.
Because Shivani is a female. So if I'm going to ask for the complement of the 4 boys that are standing, well then you may sit now. If I ask for the complement of those 4 boys, well then I can have Shivani as a complement of the 4 boys. In fact, I can have any other one of the females seated here. Do you agree?
Yes, sir.
But if I ask for the complement of these boys here, you will not tell me the lady passing on the street, because she's not even under consideration. I'm only considering the students who are in this room. Alright? Because the students who are in this room now form my universal set. So whenever we're dealing with complements, we only consider the elements which are part of the universal set. Right, Danica? Good. We only consider the elements that are part of the universal set. So it therefore means if we want what is a complement of M, we're only looking for the elements that are outside of M but still within the universal set. So what are the complements of M?
2, 4, 8.
2, 4, 8. Now what is wrong here with me listing this here? What is wrong here?
No commas.
No comma.
Yeah, no commas, so I have to put in my commas there. 2, 4, 8. What about N complement now?
3,
6, 9.
Yeah, that was fast. 3, 6, 9. Good, correct. So we can look at a Venn diagram and we can learn so much from it. And we can read so much from a Venn diagram. So while some other persons, when they see this Venn diagram, they have no idea what it is about, at least I know that a set of students, grade 8 students, could look at a Venn diagram and interpret it for what it means. Any questions? No. Well then I will give you a question. And this time for this question here, this new diagram on the board here we're considering, I'm just giving you a chance to whoever finish off copying the answers to the last one. But we will look at this other diagram here. This is the universal set. And observe it is even different to the previous diagram. So we are considering different examples. Now for this diagram, you're going to list the elements again. And we will start off by listing the elements in the set P. What is P equal to, class?
A.
P is equal to A. Anything else in P?
Q.
But Q is the name of a set though. We're looking for the elements inside of P. What are the other elements in P?
B, C.
Someone is saying B and C. Are you sure B and C is inside of P?
No.
No, sir.
Let me see who's saying B and C is inside of P. Like we have some invisible persons in this room because I heard somebody say B and C. Where is B and C?
In Q.
And where is Q?
In P. C.
Now tell me this. We are in this room here. Alright? And this room is part of a large building. Are you in this room?
Yes.
Are you in the building?
Yes.
Good. The building is in Guyana. Are you in Guyana?
Yes, sir.
Oh, I thought you would tell me you were not in the building. You're only in the room, you're not in the building. So then, if B and C is in Q, and Q is inside of P, is B and C inside of P?
Yes.
Yes, it is. So P, the elements in P are A, B, and C. Is that clear?
Yes.
Quickly then, what are the elements in Q?
B and C.
Correct. What are the elements in R?
D.
Very good. The elements in R will be D. P intersect Q. All right. Elements in P intersect Q.
B, C.
Correct. Very good. Very, very good. P intersect Q. What about the elements in P union Q?
A, B,
P union Q.
A, B, C.
Correct. Very good, very good. P union Q, A, B, C. What about those elements in? Look at this set now. Somebody said, wow. P union Q union R. What are the elements in that set?
A, C, D.
Very good. I think I can find one that will be a bit difficult for you. Let me see. What about this one here? Yeah.
Empty set.
What are the elements in this set here now?
Empty set.
No man, you sure?
Yes, sir.
Why is it empty set?
You're not young.
Isn't B in common there? Isn't B in common with P and R?
No, sir.
What about D?
No, sir.
There's nothing in common, so we say that this is the empty set. Alright? What about Q intersect R?
Empty set.
Is the empty set. Good. Correct. So you see again, I'm proud of you students, because again we can look at a Venn diagram and we could read off so much information from this Venn diagram. Alright? And I hope that we will be able to apply it to solve almost any problem that we may come across in sets. What is the relationship between P and Q? The relationship between P and the Q. Observe that all the elements of Q can be found in P. That should be a big hint. If all the elements of Q are also in P, what do we say is Q to P? Begins with S.
Subset.
Yeah.
Are you sure?
It's subset.
Are you sure?
Yes.
Yes, sir.
So tell me something about a subset. So anybody, tell me something about subset. Because you're saying subset. Tell me something about subset. Anyone? Yes.
Sir, a subset is sets that you can get from a bigger set.
All right. Bibi is saying that a subset refers to the sets that you could get from a bigger set. So, for example, Q is part of a bigger set. That's what you're saying.
Yes.
So then Q is a subset of P. Very good, Bibi. So we can say that Q is a subset of P. And we can also go on to say in reverse that P contains Q. We can use any one of the notation, right? It is correct to use any one. We say Q is a subset or is contained in P, or we can say that P contains Q. Do you have any questions, class? All right, let us consider our last question for today. Now, I'm going to give you a diagram here, and you're going to make copies of this diagram. You will make 5 copies of that diagram. Please look how the loops are joined. Look how the loops are joined. Make sure you copy the exact diagram. A universal set with 3 subsets P, Q, R. Make 6 copies of this diagram. Are you finished? In the first copy of your diagram, you're going to do some shading. In fact, for all of them, you're going to do some shading. But for the first one, you will shade the portion of the diagram which shows P union R. P union R. You will shade that. P union R. Who's finished? So we're looking for the set P, and we're looking for the set R, the subsets P and the subset R, and we will shade them quickly. But let me do this first one with you. P union R. P union R means I'm looking for everything inside of P, so I shade the entire of the set P. I want the entire of P together with the entire of R, so then I shade the set R. So this is the answer to the question if you're asked to shade the region P union R. So this was the first part, first question. Second one. What is this saying?
P intersect Q.
Yes, correct. P intersect Q. P intersect Q will be which region?
In the middle of P and Q.
In the middle of P and Q. Good, correct. In the middle of P and Q. All agree to this? Shading here in the middle of P and Q? Yes. This region here? P intersect Q in the middle of P and Q. What about this one? Just now we spoke about complement. P complement. P complement. If we're going to shade P complement, what will it be? P only. Someone is saying P only. What did we say about complement just now? Not inside of P. So P complement will be the things that are not inside of P. So where do we shade?
Q and R.
Q and R. Someone is saying to shade Q and R. Just tell me if I shade correct here.
No, sir.
No, sir.
But you said Q and R.
Only
Oh, so which portion should I take out?
the intersection.
Intersection.
With which two sets?
With P and Q.
Okay, good. So you agree to this? All agree to this?
Yes.
But I don't agree though.
Sir will give us.
So
Because P complement for me is saying to shade everything outside of P. And everything outside of P will be all here. Not only what is in Q and R, but everything out here will be P complement. Is that clear?
Yes.
Everything outside. Not only what is in the other two, but everything outside. All right. P intersect R, you will shade. P intersect R. That one should take you 1 second to shade. Are you finished with P intersect R? Let me draw the diagram across here. Yeah, where do we shade there? For P intersect R, where do we shade? Everybody's silent. Where do we shade? Where is the intersection with P and R there?
They don't have no intersection.
There is no intersection. Correct. There is no intersection. So there is nothing to shade there. I wonder if some people went about shading. Huh? Nobody went about shading. Yeah, there is no intersection. Good. We have a last question here with P intersect Q, union Q intersect R. Let us go through this one quickly together. P intersect Q will be this region here, and we want it together with Q intersect R, and Q intersect R is that region there. So if we ask to shade P intersect Q and union it with Q intersect R, it will give us that region which we have there. Is that clear?
Yes.
Any question? So it therefore means given any direction, the Venn diagram, I know you students will be able to answer questions on it. Am I correct to say that?
Yes, sir.
So then I look forward to the next lesson, because in my next lesson, I'm going to really see whether you guys can really answer any question on Venn diagram. Good. Bye for now, until we meet again for the next class.